Hello everyone. Let's go through the easy LeetCode problem of checking whether the two strings are anagrams in Java. While going through it, I will try my best to explain the thought process, so this may help you in your future tasks. Let's read the problem. Given two strings s and t, return true if t is an anagram of s and false otherwise. Let's understand the task. First of all, what are anagrams? We can read the LeetCode explanation. As it says, an anagram is a word or phrase formed by rearranging the letters of a different word or phrase using all the original letters exactly once. I don't like this explanation though. I think it is worded a little bit poorly. For example, using all the original letters exactly once, at the first glance, misled me to think that a particular character can be repeated in each of the words, meaning words from the first example, anagram and negagram, would not comply because they have three A's. Maybe it's just me, but LeetCode.io has the same task, which I think explains an anagram in a much clearer way. It says, an anagram is a string that contains the exact same characters as another string, but the order of the characters can be different. Back to LeetCode. It also gives us two examples, one with anagrams and one without them. As you can see, anagram can form negagram, but rat can't form car. Now all we need to do is come up with a good way to check that given words are indeed anagrams of each other. A brute force approach would seem to create a list of letters from one word and check this list against another word. However, if these words are too big, then that's going to cost us, especially since letters can repeat multiple times. A much more efficient way would be using hash map, which keys are individual characters and values are the number of times that those characters appear in a given word. Both of the words work with the same hash map, but they work slightly differently. One of the word's characters add to hash map values, while the other word's characters subtract from them. Let's look at the first example to see how that helps us determine if they are anagrams or not. We go through them letter by letter. For example, the first letter of the first word is A, so we put the key A and add to its value. The first letter of the second word is N, so we put the key N, but we subtract from its value. We continue doing it until both words run out. As you can see, for these words, the end result contains 5 keys, but all of them have 0 as value. Since those words are anagrams, each key's value was initialized as 0 and had the same amount of additions as it had subtractions, so all keys were reset back to 0. Now let's do the same for the second example. The result has 4 keys, but not all of them are zeros, because the amounts of additions and subtractions to those keys are not equal. We can safely say that this algorithm works, and we can also safely say that this is pretty quick, because we work with a hash map with a relatively low number of keys. Let's see the code with this solution. At the start of the method, I have a small if, just as a quick check, because we can safely assume that words with a different number of characters can't be anagrams. Next we create our hash map and we go through both words simultaneously, since there is no need to go separately through words with the same length. Letters of the first word add to the values of our hash map, and letters of the second word subtract from those values. The last part of logic is checking whether all values of the map are zeros. Let's check this code in action. All of our cases pass. I would like to point out that our solution is not at the top in terms of speed, but let's check what is. For example, this solution. It is fast thanks to Java built-in sorting solution. It works, but in my opinion it's not a good solution if you want to solve coding challenges with your knowledge of algorithms, instead of something that Java has built in. I also wanted to see time and space complexity, which LeetCode.io thankfully provides. As you can see, time complexity is O(n), because we need to go through both full words. Space complexity is also O(n), because we create a data structure that holds data about given characters. If you have any questions, feel free to ask them in the comments. And if you enjoyed the video, please like and subscribe. It really helps the channel grow and lets me keep making more content like this. Thanks for watching.